The next time you buy a canned soft drink, consider this. That aluminum can will always be recyclable. Unlike plastic, aluminum never deteriorates, no matter how often it's melted down and used again. The next time you buy a canned soft drink, consider this. That aluminum can will always be recyclable. Unlike plastic, aluminum never deteriorates, no matter how often it's melted down and used again. Aluminum cans are so lightweight that it's hard to believe they're made from a huge roll of aluminum sheeting that weighs 9 metric tons. The sheet is about 1.5 meters wide and as thin as construction paper. A roll like this is long enough to make 750,000 drink cans. The sheet feeds into a press that punches out round pieces that'll be formed into cans. The punch press actually performs 2 operations. It punches out a disc 14 centimeters in diameter, then bends it into a cup. What's left of the sheet gets compacted and sent back to the aluminum factory where it's recycled into new rolls. The cup goes into a machine called the draw and iron body maker. A tool draws out the aluminum, forming the body of the can. The tool is lubricated so it won't tear the aluminum while stretching it. The lubricant also acts as a coolant because the aluminum heats up as it's being worked. Once the body is formed, a trimmer cleans and straightens the edge. Now the cans move along upside down on the conveyor belt over to the washer. The washer performs a 6-stage cleaning. The first 2 washes are in hydrofluoric acid at 60 degrees Celsius. The last 4 washes are in deionized water, neutral water with no pH, also at 60 degrees. The cans come out of the washer and go under a hot air dryer. They're now shiny because the hydrofluoric acid wash removed a thin surface layer of aluminum. Next, a roller passes over the cans, coating the bottom rims with varnish. This varnish coating allows the cans to slide easily on conveyor belts and in vending machines. It shows up as a blue ring under ultraviolet light. The cans are now ready to be printed. This rotation printing system can apply up to 5 colors, one at a time. The machine then applies a layer of varnish to protect the ink. This is what the print and varnish process looks like in slow motion. And here's the actual speed, 1,800 cans per minute. Next, the cans fly through an oven that instantly hardens the ink and dries the protective varnish. The next machine sprays a water-based varnish on the inside of the cans. This creates a barrier between the drink and the aluminum, so the drink won't end up tasting like metal. It also prevents the aluminum from being eaten away from the inside by the acid in carbonated drinks. Next, the cans go through a machine called the necker, which forms a 5-centimeter neck on the can. This is done gradually in 11 steps so as not to puncture the paper-thin aluminum. The next machine, called the flanger, forms a curved-over edge at the top of the can, which will later attach to the pull tab cover. The cans pass through a sophisticated vision system that photographs the inside of each can. Any can that doesn't meet standards, that has a bump or ink inside, for example, is automatically canned from the production line. They strap the finished cans onto a pallet. From here, they're shipped to the drink company, which fills them, then attaches the pull tab cover. Drinking water that's fresh, clean, and crystal clear is something many of us take for granted. We might not give it a second thought, but between the source and our tap, a lot happens to make that water fit to drink. Our water may come from Mother Nature, but it's far from pristine. It starts its journey to the treatment plant through a water intake pipe. On the wall of that pipe, about 2 meters down, is a 15-centimeter hole. Covering that hole is a metal grill designed to keep out large debris such as tree branches. The water flows to a pumping station where it goes through a preliminary screening. A giant revolving screen removes fish, garbage, and grass. Once they remove the debris, a low-pressure pump moves the water into the treatment plant. The untreated water, called raw water, is dirty and smelly. So they first add a powerful form of the chemical element carbon, called activated carbon. It absorbs contaminants such as solvents and pesticides. That rids the water of bad taste and odor. From there, the water then goes through a series of mixing tanks. The first tank holds a chemical called aluminum sulfate. It acts as a coagulant, a substance that thickens liquid into globs. In the raw water, the aluminum sulfate forms tiny sticky globs called flocks. Bacteria, mud, and other impurities stick to those flocks. Then the flock-filled water moves on to the second mixing tank. The second tank holds a chemical called polymer, which is essential to the next step of the process, called sedimentation. 5 pipes inject the water with superfine particles of sand, called microsand. The polymer coats the sand, making it sticky. The grains of sand then stick to the flocks in the raw water, weighing them down even more. The water then flows into a settling tank where the flocks, because they're heavier, settle to the bottom. You can see the result in this demonstration. The water is finally clear, but it's far from drinkable because it's still full of bacteria, viruses, and other organic matter. So on to the next step, filtration. The water flows onto the top of the filter, then trickles downward, passing through a layer of anthracite, a type of coal, then through a layer of sand. This filters out any remaining particles, which then flow to the middle. But the water is still teeming with bacteria and viruses, so it has to be disinfected. They add 1.9 milligrams of chlorine per liter of water, enough to kill off those germs and bugs. They add a mineral called silicate to prevent calcium buildup from blocking our water pipes. The treatment plant sends water samples to government inspectors who continuously monitor the water supply to ensure it meets safety standards. The amount of chlorine remaining in our drinking water is 0.6 milligrams per liter. The chlorine gas the plant uses is highly toxic. Should any leak out, emergency teams would have to evacuate a 10-kilometer radius. So the plant stores the drums of chlorine in a high-security area. It's taken about 45 minutes to turn raw water into treated water. Now these electric motors will pump it through underground pipes right to your tap.